Hey, good morning, everybody. Good evening, wherever you are. So thanks for joining me today. I'm going to talk through building games with Arbitrum and Tableland, but actually it's going to be a mix of a bunch of different tools, and I'm going to show you how to put together some basic tooling and kind of have a really nice game stack. And so I put together this little GitHub gist where you can find links to some of the resources I'll blast through today. I'm not going to go through like setting up tooling or getting your IDE set up or anything like that. So if you're not experienced with these things, you might have to go and read some other tutorials to get started there. We're going to jump right into building, and in fact, I'm going to work through some examples that I've already built and how they work, so that I'm not sort of writing code live. I actually do want to do some live coding streams, but those will obviously take a lot longer than what we've scheduled today, which should be about an hour if everything goes well. And so, yeah, the focus today is going to be on Arbitrum and deploying a contract on Arbitrum for playing a little game. And so you can read more about this example I put together in the second link of my gist. And so this is an example I put together a few weeks ago, which just does game state management in smart contracts, where the metadata about the game, sort of the more complex information, is pushed to Tableland, where it can be queried by both the NFT, like the interactive NFT, and in today's example, I'll have a small dApp, which shows you the full collection and lets you interact with any NFT in the collection. So if you go to that repo, you'll see that I actually built it originally on Polygon. Yesterday, I went through the work of creating a branch for Arbitrum, and the flow is pretty much the exact same. If you actually go and take a look at the commit here to convert it over to Arbitrum, you'll see pretty minimal set of changes. You'll need an environmental file with two different environmental variables around your this should say the Arbiscan API key, as well as an Alchemy API key. That's just how I'm going to deploy it. The reason I have both is I deploy the contracts via Alchemy, and then I use the API key originally on Polyscan, now on Arbiscan to push the ABI so that this contract will be interactive on Polyscan or today on Arbiscan. And then a handful of other changes. I actually made some fixes to the smart contract for it to run better, et cetera, et cetera. So we'll go through all of this today, but just so you know, it's not a huge number of changes from the original work. And I'll show you where we're going, where this is going to end up. So in the example I made a few weeks ago, one thing that's really handy about NFTs deployed to the Polygon Mumbai network, their test network, is that you can actually see them on OpenSea. So OpenSea has support for Mumbai. And so here's my game of Hangman, and you'll see that there's just 3 games that have been minted. So the way the game is played is you actually mint a new NFT, and when you mint the NFT, you're gonna give it a secret word. Well, secret, it's actually contained in your transaction, obviously, but just for the fun of today, we're doing it this way. There are some more complicated ways that we could do that using other protocols or tools to keep it secret. But for today it's sort of secret. And so you push your word into a new NFT. So now this NFT has a secret word in it, and people can come along and make single letter guesses to play this game. And if too many guesses are made without the word being discovered, the hangman is killed. And if the word is guessed in a sufficient amount of time, the NFT is won. And then this is an active game where people are still able to guess. Now, OpenSea doesn't have the tools for allowing you to perform these interactions right in OpenSea. Like it's not a great place for actually playing NFTs. And so for that's why we went over to Arbiscan, or previously on Polygon Scan. So in Polygon Scan, for example, we can just go back to the mainnet and I'll show you the deployed version on Polygon and how that works. So on Polygon, you can go right to the contract, and because I verify the contract on Polygon Scan, it knows the API and it knows how to call the different methods. So you can actually connect your wallet and mint right here. And so you'll mint an NFT to yourself, and you'll insert your secret word. So, okay, so that's the quick overview of the game. And so now we're going to go through how it's actually built and some of the key things I kind of learned putting this together that will help you create your own game. So again, if you're following along, you can jump into this repo, you can clone it and just check out this Arbitrum branch, which should be ready to go. You'll just need to supply some those environmental variables, which are mentioned down here. Okay, so let's work through this. I have this this project open in VS Code here. So let's jump right into what's happening in the contract. And if you have questions today, feel free to ask them on YouTube or in our Discord. Actually, there's a question here on YouTube. Let me just get that gist out to them. Here you go. Yeah, so yeah, feel free to ask questions, and I'm happy to like pause or go back and explain things in more depth. So this game is made up of essentially just one contract. Actually, when you deploy it, it's multiple contracts, but that's because we're using OpenZepplin to fill in a lot of things that we don't want to write ourselves. So if you're not familiar with writing Solidity smart contracts, OpenZepplin maintains a bunch of really great extendable contracts and contract interfaces and tooling that you can use and avoid writing a lot of these things on your own and just kind of like lean into best practices. And so I do that in all of my examples. So in this smart contract, we're really just defining the core mechanic. It's an NFT, but when somebody mints it, they need to actually give a new piece of information, which is the secret word, which then makes it playable. And then it has the logic for what to do as somebody's playing it, and the logic for what to do if somebody runs out of guesses or anything like that. And so, okay, so some key bits here. We've got two structs here, which are just where we're going to store information in the smart contract. And you'll actually see that what's really nice with storing data in Tableland is it provides a really great hybrid approach where you're actually still going to store some key bits in the smart contract itself, just less of it, just like the key mappings and indexes about which tokens exist and how many guesses are left on them. Those things you might want on the smart contract because you want to execute logic in the smart contract around them. But the metadata for the game ends up on Tableland, where it's really easily queryable and buildable into your dApp and all that good stuff. So I keep two things, which are each game is going to get one of these structs where we're just going to track the number of remaining guesses and things like that. And then we're going to keep a high level struct that's going to have just like our game store ID and our game store name. So this is the table on Tableland that's going to track all the different games that are in play. And then a mapping for every game. It's going to have one of these structs. So, all right. So then this is our main contract. These are all things that I'm pulling from OpenZepplin. So I won't go into depth here about how I chose these things, but one really great resource when you're building any smart contracts and just trying to get started, and I dropped a link in here, is actually the OpenZepplin Wizard. And so I've gotten a few of my examples started by just going right here. So if you're trying to build an NFT for the first time, you can go right here and give the metadata about your NFT. So you could have a new NFT. All right, of course, no spaces. And then you can make it mintable. You can make it enumerable. You can make it burnable, and it will fill in all the basic information from which you can then modify it. So I make mine upgradable, which makes them a bit more complex. And then what's really cool, and I've only done this a few times, is you can open that right in Remix. And that's a web-based IDE where you can go through the steps of actually editing this further, testing it, compiling it, and even deploying it. And so if you deploy it, you can choose your network here. And so they have a few different test nets, and you can inject it. You can inject it into it using Brave. Let me just get my wallet set up. Great. Cool. All right. So yeah, so I just was getting my wallet ready to go. And so what's cool about Remix is by doing this injected provider, if you're using MetaMask or Brave, it makes it very easy to use Remix to deploy to different networks. So here, my wallet is connected to Arbitrum's Goerli, so I could actually use Remix to deploy this to Goerli. I'm not going to do that today because I do a couple of additional things that I didn't want to set up in Remix, though. I think going forward in our examples, it'll be good practice to include links right in our GitHub repos that will allow you to open the whole project right into Remix. So I'll be working on that in the future too. So those are just a couple of resources for you to get started. But now back to the main show here. Okay, so that was all stuff that you can actually get through OpenZepplin, and a lot of this you'll get by using that wizard. So let's get to the main bits. This initialize, if you're not familiar with it, is just about upgradable smart contracts. So you'll see this instead of the constructor. And I do a lot of my examples as upgradable smart contracts. It makes it much easier for sort of testing and deploying multiple versions as I get it closer to what I think the final thing needs to look like. So, okay, the first thing this contract's going to do is it's going to have this function called init game store. And you'll see this in a lot of my examples too, a function very similar like this, init something. And what this does is it's going to be the contract's first interaction with Tableland. So if you haven't used Tableland to store or build on data yet, one of the really cool features of Tableland is the way the access control works, the way table ownership works. You can actually create tables directly from other smart contracts. And when you do that, it scopes those tables to only ever be updated or mutable via that smart contract address, which means no wallet out there can possibly change that data in that table except for this original smart contract, which is super powerful. And in this case, with an upgradable smart contract, it actually is owned by the top level proxy. So as you upgrade the contract underneath, it still owns that table, and you can keep pushing new data to it or modifying data. So what I do in a lot of my smart contract examples is I create one sort of like top level table on Tableland that's going to store a lot of metadata about things going on. And that could be, that could be a table that stores a row for every NFT created, or it could be things like, player interactions, game levels, scoreboards, leaderboards, things like that. And so here I'm just actually going to create a game store table that will contain a row for every game created. And it will it will hold just sort of the public information. So this word is actually, you'll see later, is only the currently known version of the word. And so if it's one, it would be the complete word. And you can see some other intuitive bits of information stored there. So yeah, so this is like this is like a great intro to Tableland, in a nutshell, which is you write really straightforward SQL that you can find in kind of any tutorial or workshop. about SQL, and you can create tables. And so here it's actually this SQL is going to be sent to the Tableland registry, which is another smart contract on the network. I didn't show actually that this is actually being pulled from a little utility we have. So on any network you deploy to, you can run this utility and it will tell you where the registry is and actually give you back the connection to that smart contract. So here we're going to call this function create table on the Tableland smart contract. So that once that's called, we're going to get back the ID for that table. That is a token ID actually. So every table is an NFT. So that's the token ID. We also want to just store the full name. And so you'll see the full name of a table on Tableland is made up of three things. It's a prefix, which is user defined. So I just created one just for nice readability on the network. That's just game store. And then it's underscore the blockchain ID, the chain ID of the blockchain that you're on. And then one more underscore, and then it's going to be this token ID that you get back from creating. So that's it. So now when that is run, this contract now will own this table and be able to start inserting or modifying data within it. So this gets run when the contract is deployed, or it should be run every time the contract is deployed. And I'll show you how this contract is deployed in a second. Okay, so all right. So the next thing that we want to do is once this is deployed, we want to let users mint games. So let's jump down to the safe mint function. So this we make public. So in this contract, I don't want to charge people. They're free to mint. So anybody can come along and mint a new game. And when they mint the new game, they're going to get a new token ID. And then that's going to be transferred to them. So they own it. They're going to own that NFT. Pretty straightforward. There's two things that are going to happen as well in that process. And I'll show you each of those here. The first one is just going to create a new game, obviously. So this token is now attached to a game that is in a playable state. And it's going to store the proof. So this store proof thing, you could skip it. It's just playing with the idea of obfuscating what the actual word is on the smart contract. But of course, you could go back to the transactions and find them. So it's like if you want to cheat, you could cheat. It's a little bit like if you're playing Scrabble and the people you're playing with walk away from the table. Of course, you could cheat, but this isn't a game for money or anything like that. So, right. So we really want to focus on the create game. So the create game function is going to take the address of the person who created it, the word that is the secret word that the people need to guess, and then the NFT token ID, so the token ID that they just minted. And all it's going to do is go ahead and insert that data into that table that is owned by the smart contract. So you'll notice that this function is being called by a user. So they're going to call the safe mint, but then it's the smart contract itself that calls Tableland to run new SQL, which means it's going to have the ability to edit table and data in that table, whereas the user doesn't. The user couldn't go straight to Tableland and change the data, but because they're calling smart contract, the smart contract makes a bunch of decisions about how it wants to change that data, and then it runs the SQL. And so when it creates a new game, it's actually just going to create a little SQL statement for the current game state, which is, which token it is, what the guesses, what number of guesses are left, and things like that. So a couple of notes about how the game is designed. It's very basic, but letter count is just the length of the secret word. And so that's going to be used for rendering the game of Hangman later. Like, as you probably saw really briefly, but like when you're playing a game of Hangman, you always see the like blank dashes underneath. And so you want the game to be able to render that without actually pulling the secret word into the front end game. So it's just going to get the letter count. And then the remaining is the remaining guesses for this game. And so you'll see I just hard coded that as when a game starts, there's 6 remaining guesses for the game. And that's it. So that's the game state now stored on Tableland and kind of maintained through the smart contract. So the next kind of interesting things to show here is sort of how the game is played and what happens. So the function that we make public for everyone to take a look at is the guess letter. So this is the base. This is like, in this example, this is like the playable bit. This is the single button that you have in the game. And I tried to make this example, I tried to pick an example that would be really, really simple, that you could extend on. And so this is really like intentionally just a single button example. So I got a question. So all the guesses will be put into a table, not just the correct ones. I'll show you that in a second. Actually, I didn't make it so that it tracks the incorrect guesses, but or even the correct ones. But you can see the correct ones in that currently known word. And so, but maybe we can make a tweak at the end here to show how I might do it so that all guesses are stored. So let's come back to that if we have time. All right, so the guess letter, yeah, so the guess letter, all it takes is the token that's being guessed against and the letter that you want to guess. So you see a game that you want to play, so now you come along and you want to guess. So let's see, so the things that are going to happen, okay, it's going to run this little internal function that's going to do the logic of checking whether there are more guesses. Oh, sorry, no, whether it's correct. Yeah, so whether it's correct and where it was correct. So this is actually going to take the word stored in the smart contract. So the secret is contained in the smart contract here. And it's going to check. So like if your word is two, TWO, it's going to come back and somebody guesses W, it's going to come back and tell you that position one is correct. And so it's going to have a 1 in this array. And then this is obviously going to come back as true because the array is going to be bigger than 0. So a better example might be door, DOOR. If somebody guessed O, this is going to come back with an array containing 1 and 2, and this is obviously going to come back as true still. So that's just telling the guess letter function if it was correct and where was it correct. And so then we're going to create a new word, which is going to be the underscores with the underscores replaced with the correct ones. So just to show that sort of live, if the unknown word had been underscore, 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 and that's for door, and then this person comes along and guesses, oh, the new word is going to look like this. And you can dig into this smart contract and see how I do that. It's pretty straightforward. But the reason we want that string is because it makes it really simple for the rendering of the game later. And so we can kind of skip the rest, but basically it's saying if the user guessed it correctly, let's go ahead and update the row in that table that we created and set that new word equal to that interspliced thing that I just showed you with underscores for the unknown and the correct letters for the known. And we do that by, again, vanilla SQL. Update this table that we created, set that word to that value I just showed you, where the ID equals this token. So I might not have illustrated that super clearly, but in this like metadata table that we created before, we have this ID column, which is our primary key. And we're going to use that by every row we put into this table, we're going to store the token ID there, which will always be unique. And then later when we want to update that row, we can just filter our update statements by that token ID. Okay, so a guess is made, and that's what will happen. The only variations of this are if it's incorrect, it's gonna count down the remaining. And there's a few different ways that you could do this with SQL. Like you could just set it to itself -1. but I just wanted, well, you can do that. Or here I know it, so I just put it equal to the new value. So that's a different update. So this is to answer that question about storing the incorrect ones. I would just store a new column called incorrect guesses, which had a list of letters. And I would set that here at the exact same time. So I would just go like incorrects. And then I'd have some, some letters in there. And that doesn't need to be stored in any sort of fancy way because we can just decode it in the front end to display what we want to display and let people know what guesses have happened. And that's fairly easy where like you could do some simple SQL-based string concatenation. So you don't need to maintain the incorrect guesses in the smart contract in that case. And that's a really like simple insight into where Tableland gets really valuable for moving information that's not critical for the smart contract into the metadata storage. So that's okay. So I was showing some variations beyond the just normal update for a correct guess. So this is the incorrect guess. There's also a correct guess where it's the final letter of the word. And so in that case, we update the word, and it would be, before I showed, it would be something like that. But in this case, if they had gotten the final letter of door, it would set it to the final one, so anybody can see now the winning word. And we also store in there who made that final guess, so who the winner was. And actually, kind of fun thing I did here, when somebody wins, I actually transfer the game to the winner. So the last person to get the person to guess the final correct number sort of collects that winning token. And likewise, if a game fails, we do the same SQL for counting down the remaining. But if that ends up being a 0 up above, we detected that it was the final guess, and we're going to transfer this token back to the smart contract. So this smart contract will sit there collecting all failed games. We could burn them or anything there, but just sort of a simple little mechanic I baked into there. And same thing, any of those SQL statements that were generated above after all of this logic is run, it's just going to fire against this run SQL, and that's going to hit the Tableland registry. But because this contract owns that table, it has the ability to make those updates. That's about it. Like those two functions allow you to do some really cool things. So, all right, in this repo, I do just a couple other kind of like handy things if you're building, and then we'll go into like what to do with this game. So the first thing I do is I have a script in here called deploy. And this is like the first script you're going to run once you have your contract ready. So this is the game levels contract we were just looking at, and it's going to deploy it to the network. And just based on our configuration in this repo, it's going to deploy it to the network that we choose, and give us a bunch of information. It will store also. It will also store a little environmental variable for what the contract address is, because we're going to use that later. So if you deploy it, it's going to store what the contract address is in this little environmental variable, because then later I have a script called update, and update will grab that address. And because this is an upgradable contract, it will use that to overwrite the function or the contract in place. So it uses a proxy address. I won't get too much into that, but it allows you to sort of keep developing with a single address on the network, and make changes and fixes as long as you're not making any severe changes to your contract. So if I was building this, I would go, I actually have some helper scripts in here. So I would go npm run deploy. It would hit that deploy script, and then later, if I made a change to say my mint function, I could come along and just do npm run upgrade, and I'll show you both of those in a second. And then the last kind of handy thing I do here is I just have this verify method. And so this verify is going to use hard hat to go ahead and fire off the contract ABI to the network portal, so Arbiscan or Polygon Scan or whatever you're using, so that then you can explore the contract right in those portals and execute functions. So let me show you that whole flow now. So I'm in that repo. Fingers crossed I made all the correct changes here. Okay, I'll show you that in a second, something else here. So all you're going to do is run the npm run deploy, and this is going to compile that smart contract and push it. Here I'm using Alchemy. It's going to push it over my Alchemy account. You can create a free Alchemy account, get an API key, and follow the instructions in this README to drop that API key into the repo, and then this deploy function should work for you. And you'll see it goes ahead and deploys the proxy. So that's what I keep mentioning. This is an upgradable contract. So this is the key address that we're going to want to take a look at, and then links the proxy, and it verifies. So if you include your Arbiscan API key, which you can again get for free, drop it in your environmental variables here. This will just work and push that deployed contract for you. So right. So let's take a look at Arbiscan. So you'll see my link in the gist goes to the Goerli version. I'm using Goerli here. I'm not deploying to any kind of mainnet at the moment. So if we go ahead and just drop that contract in, you'll see two things happened. And I'll go back, I'll unwind here and show you the second thing. So the first thing is that there's the contract creation. So I ran the npm deploy. It pushed this contract. It's created. The second is it did the init game store. So that's the function I showed you already. The first one that I said would be run when it gets deployed here, init game store. And so you could actually put this right into the initialize function, and then it would just happen when you deploy it. But I just wanted to show for demonstration purposes another way to do it, which is when you deploy, you can call as many as you want right in this deploy script. So here I'm gonna I go ahead in my deploy script, go ahead and get the contract. I deploy the proxy using hard hat. So that pushes the contract to Goerli. And once it's deployed, I'm then gonna go ahead and finish setting up the proxy, but then I'm gonna go ahead and execute that init game store. And that init game store is it's only possible for me to run that. So because I'm the one that pushed the contract, I can run the init game store. And now that's set up, I never need to run it again. So you'll see in the upgrade script, there is no game store creation. It only needs to be created once. So those are the two functions you see running there. Now, this is a really cool, yeah. So I have a request here to share the contract address. Let's see here. I'll tell you what, I will, if you have the gist, I will just go ahead and create a live section here for easy sharing of that stuff and getting it later, because I know a lot of these chats might be lost or whatever. So if you just refresh the gist, you can have that now. Yeah, so, okay, so, okay, that's what I was gonna say. Really cool thing here. And this, I've gotten hung up on this in the past, and so just calling it out. This contract has a method here, or not a method, an extension from OpenZepplin called ERC721 holder upgradable. And so this adds a few methods to your contract that are required if your contract is going to own NFTs itself. And you can see here in this, it has like what to do when it receives an NFT and a couple others. So you'll recall this is important for one reason down below in the game, is that when games are lost, they go back to this contract. So that's needed. And then there's another really important thing here is when you create that table in this init game store. I mentioned before that Tableland tables are NFTs, and this contract's going to own that NFT. So it needs to have that ability to own the NFT. And so what's really cool, if we go back here, we can actually see that happened here, and it owns this token ID 16. I haven't found a good marketplace or similar interface on Arbitrum testnets for viewing and interacting with NFTs. So I mentioned before that in Polygon Mumbai, you can do it right in OpenSea because it has support for Mumbai on their testnets interface. But I haven't seen it in Arbiscan or Arbitrum. So if anybody knows one of those, let me know, and I'll bring that up. But let's go a little bit further now. So because I mentioned, or just to mention that, in Polygon with Mumbai, I can go to the OpenSea or a few other places and see this NFT now live. But if I go back to this contract, I can now start doing things with it, but it's going to be a little bit hard to interact with the actual NFTs. So, but let me show you the process of creating a game, and then I'm going to bring up an interface for you to actually see that game. So I mentioned before that we pushed the verified contract to Arbiscan in the scripts. And so this is the real value of that, is like now I can just go right to the contract and I can interact with it in these tabs. So if I read as the proxy, for example, I can go down and I can call any of these read functions to see things. But let's go ahead and jump right to interacting. So I have my wallet connected to Arbitrum Goerli. I have some Goerli Arbitrum token. If you are following this tutorial and you don't have that token, just Google Arbitrum faucet. And I found one faucet that'll give you a really small amount. But the better way to do it is just to go to the Ethereum Goerli faucet, get some Goerli, and then go to the Arbitrum Goerli bridge and bridge that Goerli over. It'll take like 10 minutes to get that token. After the workshop, I'll drop those links into the gist. I realize I should have put them there, but just for how to do it. But if you Google it, you'll find it pretty quickly. I did that. So I took, a quarter ETH on Goerli and I bridged it over. So now I have plenty to run things for decades on Arbitrum because it's so cheap. So, okay. So the thing that we want to do, right, is mint something. So let's mint one to ourselves. And I'm going to give it the secret word of workshop. Cool. And you'll get these errors, but don't worry about them. They're pretty normal. So that mint just happened. We can actually go check it in the transactions once it completes. So that mint completed, and I got token ID 0 of the good game token. All right. Like all this stuff is really handy having that verified contract. So you'll see that anybody can now see my word. It's in the wide open. There's other ways, maybe be a good future workshop to go over ways of hiding information in your game. But cool. So we have all that. Now let's explore this token. I ran into this last night, not having that OpenSea testnets link. So I wanted to build a simple dApp. So I actually found this, Tom Hurst made a nice little boilerplate that just uses Tailwind and lets you mint. And I thought, oh, okay, all I want to do is mint this NFT and see NFTs that are already created. And so I grabbed this and forked it and tweaked it a bit here to just give me that same interface, but connected to this contract. And I can actually put this up as a different example. I'll just fork this into Tableland and make some tweaks. But we can go ahead and spin this up. So this should already be working, and we can just run. So this is our game. Oh, okay, right. So this is actually connected to the contract I was building last night. So let's figure out how to change that. think, yeah, I think I just need to change it here. So yeah, cool. So there's the token that I just minted. Now the reason this worked, so this demo requires the ABI of the contract that you created, and so that exists in this little source repo or source folder artifacts, and that would contain the game levels ABI. I dropped that in last night for the contract that I was putting together for this workshop, but the methods are all the same. So the same ABI actually just works. So I won't go through those steps, but I'll put this repo up and I'll walk through how to do that for your own contract. So now, right. So now this has both all the games that have been created and a little interface to play it. So I could actually create a new one called with a secret word of win. And now if I refresh it, that collection should have 2. And now I could play game 1, which is just the token ID 1. And I could guess those letters. Ooh. And you should see this get updated. All right, so that last transaction hasn't come through yet, but if I do one more refresh, it should come through. There it is. So it won. This is not part of the actual interface. I just dropped it in there so you'd know what game to play. Right, and now same thing. I could guess the first game 6 times, if you recall. It will take 6 wrong guesses. Get rid of those. Okay, I lost count. Yeah, so that one failed. And, you can just funny state. It's not there yet. I wonder what happens if, I guess, optimistically. Oh, I guessed the wrong game. So that's game 2. So there we go. Okay, come on. Let's clear that out. Getting ahead of myself. Clicking too quickly. Huh. Sometimes I get those and they become annoying. If anybody knows how to fix those too, much appreciated. Oh, that's funny. Okay. Something happened with that token too. I must have messed up the call or something. Anyway, really simple DApp. I just put it together last night. But you get the idea. Those are the basics. And so the last thing I wanted to show you, this DApp, is really doing minimal things. So it's calling the smart contract to get the list of tokens that exist. right? Let's try one last time. No, I quit. Okay. It's calling the smart contract to get the list of tokens that exist, and then it's embedding those tokens here. And I was just trying to move really quickly, and this is using Next. And so I tried to embed the SVG version of these. So if you look at the version on Polygon, these are the SVG versions, and they just show the current state of the word, not the full game. So they're non-interactive too, right? And then when you click into it, it pulls up this animation URL, which is the interactive bit. Actually, well, not interactive in this case because I built it for being in an iframe on OpenSea, but you could make it interactive. And so here I ran into a problem on Next that it didn't like inline SVGs, because Next is the framework that this demo DApp I forked is using. And so it tries to optimize images by pulling them server side, doing some optimization, whatever. And in this case, I wanted to pull the SVGs right from the smart contract and display them in line, which I was going to have to do a bunch of stuff to get Next to do that. So instead, I'm just actually embedding the same iframe that you see here. And so these are iframes of each game. So how are those iframes built? Like, what is the application that's being displayed? There is the final thing I wanted to show you, because this gets really cool too. So if you go back to the example repo, the example game repo, there is a folder in here called NFT. And that is just a simple front-end application, React app that displays that game of Hangman. So let's walk through that really quick. And then I wanted to show you one last like sort of beautiful flow for making that public. Right. So, okay, this is actually really cool. It's just rendering the game of Hangman as little ASCII art. So the app is super simple. It's going to query the Tableland table via the testnet gateway and just pull the state of any game. So it's going to take URL parameters that it's going to tell you which game you're requesting. So it's the same app for every NFT, which is nice. You don't have to deploy a different app for every token ID. It's the same token. It's just going to get from a URL parameter which token you're trying to look at. And then it's going to run a select statement on the Tableland gateway. It's going to pull back that information and use it to generate the game. And so you'll see like the rendering of those games. Yeah, it's just this little ASCII art. What's really cool, I asked GPT chat to create an ASCII game of Hangman, and it printed this out for me, so I didn't have to do all that, which was kind of neat. So yeah, so that's that. And so if you wanted to play with that, the way that you start pushing these game sort of interactive NFTs and everything, one of my favorite ways is with Web3 Link. And so I put a link to that resource in here too in the gist. So W3 Link is here, and they have a really nice little CLI for pushing projects up to IPFS. And so what Tableland is really great at is storing that structured metadata, the stuff you want to store in rows and columns, and you want to be modifying it through your smart contract or through wallet interactions. But what it's not good at is storing bits and bytes of like HTML or JavaScript files or images, things like that. It's not very good at, and that's where IPFS is really handy. And the two of them together is really a powerful combo. And so I just have this little React app I mentioned. And so I'm just going to go ahead and run the scripts to build it. And that should create a little app in the build folder. And then all you have to do you'll go to this repo, or go to this gist, and go to this repo, the W3 up CLI, and follow their instructions for setting it up and creating an account and a space and those things. And then all you have to do is W3 up build. So now I'm pushing that build folder, which means the root of some IPFS CID will be that app. And so we can go to that here. Cool. And it's got a default game that it shows if you don't put one. But we can go back here now. And I'll show you this in action, because what I do is, let's get the token URI of one of the games we created. So let's get the token URI of 0. And you'll see in here, it's got that URL parameter that I mentioned in the DApp, in the NFT DApp. So all we have to do is to show that game. There it is. So that's what's happening. Like every game can be rendered with that same DApp, and back in your smart contract, you just need to spit that out when somebody's asking for the animation URL. And so I actually just compile a little JSON payload right in the smart contract that includes that animation URL. And I actually did this example before I got Web3 Link working. So we could actually update this to be like that. There we go. And that would now, every game would now be rendered just like this. So that's a really simple way for building like the front end of your game, have it query the smart contract and Tableland data, put it all together and render a live game. So that's putting it 5 minutes left in the hour. I showed you everything I wanted to show you. I showed you like building a smart contract and some of the basics of using Tableland. I showed you how SQL is written in Solidity. I showed you how to push your smart contracts to Arbitrum and my example scripts for doing deploys and upgrades. One note about to deploy, you could rip this out and not deploy the proxy if you just want to deploy a non-upgradable static contract. Very, very straightforward to make that change. I showed you how the same script pushes the contract ABI to Arbiscan. So now you can execute functions right in the read and write tabs. I showed you how I mutated the safe mint function, which is worth noting. You might want to be careful about that one. It's probably violating the ERC 721 standard to make you have to put a word in during safe mint. So just a note there, you might want to do it in a more elegant way. I just was being crude for my demo, but I showed you that. And then I showed you how I built a small DApp that can read the state of the smart contract to get all collections and also render these games as well as interact with the games. And I showed you finally how I built a little React app that is the actual NFT renderer. If anybody has any last questions, I'm happy to go over any of those, but otherwise I'll push the remaining bits. I think one thing I'd like to do is rip this little NFT out, and I'll create a repo called something like example React NFT app or something like that you all can find. And I'll share that. I'll put that back in the gist once I've done that in the next 20 or 30 minutes. And so just refresh that this afternoon if you want to find that new repo. And you could reuse that for rendering any sorts of data from Tableland as your NFT. And the last thing I'll put in that gist are just the steps that I use to push the IPFS. Anyway, hope that was really helpful. Not many questions. I'll be around all day in our Discord though. So if you are reviewing this later, jump in there. Let me know what you think, and hope this was helpful. Thanks, everybody.